Hey guys, welcome to my another tutorial after 5 months. It was a long break. This time around, we're going to be dealing with buffers. Just go ahead and create a script. And mainly what I'm going to talk about is, replication and then sending stuff over. So go ahead and create like a couple of remote events, then a module script right here. You can create a, a local script right here so the client can get it. So we're just gonna require replicated storage, right? Same thing here, copy it over there. So a couple of stuff that's vital is to sending stuff, right? So example would be, let's say we'll draw it out, you know, visual learners. So let's say a player A, no, let's not do that. Let's say there's a spot. We'll call this spot A, right? So spot A that'd be in red. So whenever this player goes in spot A, and then we need every other client to play like a sound whenever it goes there because you don't want to play sound from the server for some reason. When you want to do that, what you usually do is, well, you go here and then you're gonna send this player's user ID or their instance, whatever the case may be, and alongside you're gonna send uh this name so you can properly locate it in workspace, or you're gonna send the object itself. Well, thing with that is when you're sending the name, right? Let's say this is spawn location, that is gonna take a lot of data, a lot of bytes, because well, string is dynamic. The bytes depend on like the size of it, and on top you're gonna have to, like, if you're sending an instance, you're sending a 32 bit by 32-bit integer, I think, or a byte. I'm not sure. 32 byte, I'm pretty sure. Yeah, you're gonna be sending that, and that's a lot of data that you're sending. When let's say there only can be two different locations, right? A or B. So in this case, you can only be sending small amount of data to reference this, but you're gonna send a whole lot because, well, you want it to be easy. One way, and then thing with this is, well, only if you do it only once, right? If you do it only once in the entire game, it's not gonna add up. But think about a game like Blocks Fruits or like Jailbreak, where there's gonna be hundreds of players in a server, not in one server, but in cumulative multiple servers, and they're going to be, interacting with this every like a second or so. So that's a lot of data going in and out from the server to client. And thing is, that data will definitely add up, right? That 32 byte is gonna add up. So one way to decrease this is, well, sending a reference rather than sending the whole thing. A good way of showing this would be like using Java terms, right? So in Java, when you want to declare like something that you never want to change, you do final f equals 2, right? So that means f is 2 final, and it will never change, right? I don't know why it's erroring. It shouldn't. uh don't worry about it. It should never hold up, my bad. Okay, there. So f is 2, right? It will never change. So when you do f is 3, it's gonna error because, well, you cannot change f because it is final. And that's the same ideology that we're gonna take to Roblox. So we're gonna have a module script that's gonna have an array that we're never gonna change, right? So we can do return table.freeze, right? If you want to freeze the table, you can do that, or you can just have a code that never, changes it or anything. So in this table, we can have two stuff. We can have spawn location, right? All the name of it, right? So these two are the names. Just play it to make sure it doesn't error. It doesn't. So this module script would be where we store these two. And the great thing with this is because since it's static and it will never change, this is final on both server and client. So hold on, let me change the colors. So spawn location will always be 1 as an index, and the spawn location 2 will always be 2, no matter how you play the game, which way you play the game. So think about this now. Would you rather send a number called 1, or would you rather send a whole text called spawn location, which 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 has more less of a data uses. Obviously it's going to be the number because, well, one is just one. So we're going to require a module script, and then let's say we're going to have we're going to do it for 500 cases, right? So let's just, on the locals client, we're going to do this without the whole buffer decoding, encoding and decoding. So we just do on client event connect function, right? And we're just gonna print. This just means we're gonna print everything that's being passed to us. And on the server, we're gonna wait task wait 5 just to make sure everything is there, you know. And then we're gonna do for x equals 1 2. Let's do 500 task that way. So we're gonna send a remote event 500 times, and then we're gonna do a random, like a spawn location 1 or spawn location 2. Okay, so we're gonna do remote event dot fire all clients, right? And then we're gonna do math module script math dot random 1 to 2. So those are all the indexes that are possible here, and then we're gonna send it 500 times, right? We're just gonna send the string that's in there. So if we just wait, we can see like how grave this should go up a little bit. Yeah, this goes up all the way, 3.4. And this becomes vital as you're like sending a lot of C frame and stuff, and as you work with like a lot of client based stuff when you move up and like the development stuff, I guess. And when you do this, right, obviously sending a lot of strings, let's do 5,000 instead, just to show you like how crazy it can get and how crazy it gets in most of like these big games, right? Because nobody really monitors these. Some developers, they just leave it be because, well, although this is pretty high, it's not really that high. A lot of people just look at it and they go, oh well, doesn't really matter, right? And even now, if you don't even send anything, it still has some overhead to it, I'm pretty sure. So it's not like you can do a whole, you can solve everything. But see, there's definitely like 500 point 500 kilobytes that you can, save up on, which is pretty great. So again, going back to the actual thing, right? Discard all of this. So this is 1, right? And this is 2 on our index. So instead of sending spawn location, we can send 1. And on the client, we can be like, oh, what does 1 stand for? 1 stands for this. What does 2 stand for? 2 stands for this. So an easy way to do this is, since let's say the max we can have here is 255 items, right? That means we can use an unsigned integer, which just means it doesn't have like the negative sign, right? So it starts from 0 all the way to 8 bytes, which is 255, right? So that's all our possibilities. 256 total numbers, right? That are gonna that we're able to store here. So we can find the index obviously by doing index equals table dot find module script, right? And then spawn location. And since we can send 0 as well, and Lua U tables start at 1, what we can do is we can do -1. So that means we're gonna get 1 extra. Well, if that's an integer. So we're just gonna, or 1 -1, right? That's to just safeguard the fact that spawn location does exist, and if it doesn't, we're gonna default to 1 -1. So now our index starts at 1 0, my bad, it starts at 0 and it ends at 255. So we can have 256 of these unique items, and now we can represent them as a number, right, instead of representing them as a whole string. So for now, it's gonna not print anything. No, it's gonna wait 5 seconds. Yeah, it's gonna print 0 because, well, that's what we told it to do, right? Get the spawn location index, which is 1 -1, because a number can start from 0, right? So that means 1 extra slot that we get. Now, as we said before, instead of sending the spawn location text, we can create a buffer. So buffer.create, and then whatever the size is, well, the byte, how many byte is it? And since we set our items to have only 256 limit, right? So there's not going to be more than 256 different spawn point, spawn location, then we can safely say that the most amount of bytes that we need for this is only one, because with one we can like fulfill all 256 unique numbers. If we had 280, then we need 2 bytes, and you can look up how much each like byte can store, right? It's all math. It's like 2 to the power of 7 or 8, I'm not really sure. And along with that, now since we have a buffer, and we can buffer right, as I told you guys what u means, right? That means unassigned integer. So that's ui, unassigned. Now there's different type of u's. There's u8, u16, u32, right? And then there's no u64. So what that stands for is the number of bits. So when we create a buffer, right, we create size 1. 1 means 8 bits. So if we created 2, it would be 16. And since we know the max 1 byte can store is 255, all we really need is u8. Okay, and then we can just, with buffer u8, we can what can we do? We can write, well, our buffer initially, right? And then the offset. What do you want it to start at? So I'll make another drawing. So for this, right, there's 8 slots in total. 1 2 3 4 5 6. Okay, so there's 8 slots. Okay, and now let's say it starts at right here, right? It starts at right here. That's 0 0 1 2 3 4 5 6 7. So now if we want to write, so these are bits, right? These are bits, and we want to write u8. So 8 is going to take 8 slots. So from all the way here to here, where do you want it to start? If we start it right here, then there's going to be one extra stuff that's going to write right here, and it's going to error, or you're just going to discard it. I don't know. And if you write here, obviously it's gonna start at here, and then it's gonna go from here and forth on, and all this stuff would be blank. So obviously you want to start at 0. But let's say you had like 16 different slots, and then you write 8. So all of this would be filled, and now you'd have another 8. So now you start at here again at position 8. So that's how you write it, right? But yeah, that's how you write it. So for now, we're gonna do 0 and then 1 2. Okay, and I'm pretty wrong about, right, like doing buffer 8 8. Instead, what you do is the offset is counted in bytes. My bad, not bits. So once this whole thing is filled, another one starts here, and it's gonna be 2, and it goes on, and then after 8 bytes, it's gonna be 3. That's what you're gonna do. So if we had a 2 byte buffer, you do buffer dot write u8 buffer 1 2, right? And that would be the same thing, but we'd fill 16 different slots like that. All right, but for this example, as I said, we only need 1 byte, so we're gonna go with buffer write 2. That's the value that we want, and obviously the value that we want is an index. Okay, now we're gonna wait tax.wait, same thing, 5, and then we're gonna send a remote event fire all clients, and then we're gonna send the buffer. All right, so I just wait, and it prints in buffer, obviously. So with buffer, you need to, well, like extract it yourself, because Roblox doesn't really know where your data is, right? You're setting it yourself. They can read it as F32, F64, and it'll come out as different numbers, kind of. So you need to be smart, logical, and do it yourself, so you know what you're getting, right? So now we'll do the same thing. Local index equals, instead we're gonna do buffer dot read. What did we write here? We wrote u8, so we're just gonna read the same thing, u8, same buffer, and then what offset was it? 0. 0. Now we're gonna print the index, and then we're also gonna print the index right here. So that should be same. That should be the same, right? See, both side print 0. So now when we want, let's say we want, like now we're gonna want the spawn location itself. Obviously we're gonna get the module, right? Module script. And now we're gonna do, since we did -1 here for the index, we're gonna do +1, right? So target item equals module scripts index +1. And now we're gonna print target item, and then we're gonna print the target item here, and which would be, that would just be spawn location. So if we go here now, it prints spawn location, right? Yep. And we can do this now. Instead of that, let's just make it 1, right? So it will only print like, so let's say we have this, it's gonna print that now, because that is the index 1, and that's what we're asking for when we're sending it across. See, so this can be really useful because, well, in the long run, well, ideally you want to use buffer like libraries, right? That are really helpful and stuff. That'll really put you out there, and it's really easy to use, and you don't have to do this manually. But what this does is, instead of storing all that data manually, like instead of sending all this string, everything, you only send a reference to it, which is a number, and that number will be way lighter data wise than sending a whole, like a whole string, right? That's hundreds of thousands, that's hundred times like less of a data, right? 100%, I guess, like 600, 700%. And that becomes really ideal when you want to especially replicate C frame, right? When you're doing custom replication, or you want to replicate like a certain stuff every interval, or you want the server to send out stuff like every frame or so for some reason. So this is the way to go, right? I'll pull up like a short, hold on. Alright, so another way this can be used is for obviously serialization, deserialization. And I have this whole thing written up right here. And well, yeah, this, I wrote this a while ago, so I'll just bring, I'm not gonna like, I'm gonna go through each by each. And some of this stuff here is wrong. Like for example, like the numbers here, 127 and 128, I think that is wrong. Same with like the exponential power to get that number. 2 of 8, I think it's 2 of 7. So these are some number mistakes you shouldn't really account for. It's not really a big thing anyways. So obviously creating a buffer with this size, right? How many bytes it is. So we can create it with 10 size buffer, and then you can write it in different formats, right? Unassigned integer is a signed integer, unassigned integer 2 bytes, signed integer 2 bytes, unassigned integer 4 bytes, signed integer 34 bytes. So another thing to keep in mind is unassigned integers basically have 2 times the capacity as signed integers, because what really happens when you have uh assigned to unassigned integers is, well, thing is they're both gonna have the same amount of data, right? It's not like a signed integer will have double the stuff. It's just the fact that out of the number line, right? Instead of, this is an unassigned integer by the way, instead of going from 0 to 255, it goes from, I think, -126, no, 127 to 128. I think I might be wrong here. Probably am. And then 0 would be in the middle, right? So when you're sending 0 across, it actually is, you're actually sending 127 across, right? And then when it gets there, like internally the code, like deep within the code, not anything Lua related, it's gonna do -127. So you come back to 0. Or with sign integer, right? When you're sending 0, you're actually sending 127, and then at the end it does -127. So that's another way to think about it, right? You're gonna have the same capacity, just the numbers